I want to now work problem 11 out of section 2.2 from the book. Hopefully you can read it here. So it says, it's called movie attendance. 600 people attended the premiere of a motion picture. Adult tickets cost $9 and children were admitted for $6. If box office receipts totaled $4,800, how many children attended the premiere? So what are they telling us? 600 people attended total. Some were adults and some were kids. The adult ticket prices were more, $9 than the kids. When they were finished and added up how much money they took in $4,800. And now the question is, so of the 600 people that attended, how many were children? So, let's think about this. So this problem is titled Movie Attendance. Let me write it here and then make sure what I'm writing is going to show up on the screen. So once again, we have children and adults both attending the movie, and we're asked to find out how many children attended. As always, one of the first things you can do to start working on the story problem is define your variable. And the best way to define the variable is almost always going to answer the question. For this problem, the question is how many children attended. Therefore, I'm going to say the number of children that went to the movie is going to be X. Now, if the total number of people, it tells us 600 people went, therefore, what could I say about the number of adults? If there were 600 people total and X of them were children, then the number of adults must be 600 minus X. There are only two kinds of people at the movie, children and adults. Now let's take a quick look at how we calculate how much money they make from showing this movie. Well, the amount of money, I'll say the amount of money taken in is the number of adults that went. And how much did the adult ticket cost? It says the adult ticket cost $9. So you multiply the number of adults that went times $9, and then you add to it the number of children that went. And how much was the ticket for a child? It says $6. So you multiply it by $6, right? Now they told me how much money they took in. They told us they took in $4,800. So I can put $4,800 here. What about the number of adults that went? I'm calling that 600x. 600 minus x, excuse me. The number of adults that went to the movie was 600 minus x. I'm going to multiply that times the $9 plus the number of children that went to the movie. We defined that to be x. And then the cost of the child's ticket is $6. All right, so to make it simple, for now I'm going to drop the dollar signs so I can just make this into pretty much a math problem. I have 4,800. I'll move the 9 in front of the parenthesis. 9 times 600 minus x plus 6x. So here's an equation only one variable x. And if I can solve for that x, that would be the number of children that attended the movie. So the way to solve this is, let's multiply out the parentheses. 9 times 600 is 5,400. Minus 9x, so the 9 gets distributed. Plus 6x. So now I have like terms over here. So I can say the right-hand side now becomes 5,400 minus 3x. So to solve for x, let's go ahead and subtract 5,400 from both sides so I can get the negative 3x by itself. The left-hand side I now have negative 600. The right-hand side I have negative 3x. Now to solve for this, divide both sides by negative 3. Then x equals 200. So we're saying that the number of children that attended the movie was 200. Now whenever I do story problems, when I get to the end, I always ask myself two questions. First of all, have I answered the question? Some story problems will have more than one question they're asking. Well, in this case, they only ask one question. How many children attended? And I've answered that. But then the second question, which can often be helpful, is this. Does my answer make sense? Is it reasonable? Well, if they told me 600 people attended the movie and 200 ended up being kids, that's possible. Now here's what happens sometimes. You do the math and then you get an answer of 2,000. So then you would say, they told me 600 people attended the movie, but I say that there were 2,000 kids. Well, that's not possible. And at that point, I would realize that I made some kind of math error. So anyways, the answer here would be 200 children, and that is in fact the correct answer.